With the Software Delivery Simulator, we can develop an understanding of complex software delivery systems. We can develop an intuitive shared understanding of the current system, but also perform what-if analysis to drive continuous improvement. In this tutorial, we will model a simple plan, develop, build and deploy system. We'll get lead time, process time, cycle time and quality insights from that analysis, and also generate graphics and animations to share with stakeholders. We'll close the getting started, and begin by dropping models into the canvas, for the technologies and steps involved in our process. We will first look at this process from the function lens, which will give insights about the timing of steps, flow of the overall process, and quality of process execution. We'll then look at the dynamics lens, which considers the software delivery process over time and analyzes associated process inputs and outputs. So in the function lens we'll first bring a Jira model into the canvas. Jira is going to be where we'll create our work items. GitHub will be our SCM system, so we'll bring that model in to represent the development activities. SonarQube is going to check every commit and ensure we have sufficient code quality and security. Jenkins will serve as our build tool. Once artifacts are built, they'll be stored in Artifactory. And then those artifacts will be deployed out through a Jenkins job. The artifacts will be deployed out to AWS. Let's now connect together these steps in the process, with connectors. We will also reposition this diagram so that the work with the code is at the top. And then, artifact flows are on a layer underneath that. We can generate a graphic to be able to share this process with stakeholders. We can also now add parameters to quantify step durations and step quality. We'll go back into the edit modal, and for each model add a lead time, a process time, and a complete and accurate percentage. The lead time is the duration between the completion of the step before, and the handover to the step after. So this is going to include things like wait times, if resources are not immediately available to execute a task. It's also going to include things like handovers during coordination, and gaps between scheduled activities. In this case of creating a work item, on average, we imagine that takes 5 days. Yet only about 4 hours within those 5 days are active work on the work item. That is, only 4 hours of active collaboration around the planning, and active recording of the work item in Jira. There is some associated wait time with this, and the total process from start to finish is about 5 days. We'll put the complete and accurate percentage at 80%, meaning 80% of the time, we get this step right, we get the specification right, and create the right work item. Next, we'll add numbers for development. Development is going to take on average 7 days. But the process time is going to be 1 day. Again, we use a complete and accurate percentage of 80%. Meaning, 80% of the time, we correctly execute the development work. The steps after development are going to be fully automated. We imagine this is a continuous delivery process. And so these automated tasks will all have lead times, and process times, that are equivalent. So let's imagine 5 minutes for these SonarQube validations. And we'll imagine that 25% of the time, 1 out of every 4 SonarQube scans, results in a code quality issue that warrants rework. The next automated task is the build, which we'll put as 10 minutes. And 90% of the time we correctly produce artifacts from that build. Storing artifacts has no associated duration, so we'll leave the lead time and process time at 0, and set the complete and accurate percentage at 100%. Deployments take 10 minutes. And are successful 95% of the time. And finally, our deployment target has no associated duration, and we'll set the complete and accurate percentage to 100%. So now we've modeled our process. We can again generate a graphic to share with stakeholders and collaborate around. We can also download our simulation here for later reuse or editing. And we can of course now generate results and insights about the process as a whole. We'll do that with this execute button here. So we see now, for the total process, that the lead time is about 12 days. This is somewhat unsurprising, since the 2 manual steps involved in this continuous delivery end-to-end process take 5 days and 7 days. So the manual processes are dominating this lead time. We see that the actual time spent adding value and actively working on this process is about 1 day and 4 hours. Much less than the 12 days total end-to-end. This leads to an activity ratio of about 10%, meaning only about 10% of the time, we are actively working on this work item, associated commits, and artifacts. There's wait time, and potential waste, in this process. We also see that the complete and accurate percentage for the whole process is about 41%. Meaning, less than half the time are we creating a work item, developing it, building it, and deploying it completely successfully. More than half the time, we run into an issue, a failure, or rework during that process. For more complicated processes, we can bring in things like structural models, which allow for parallel flows and more dynamic processes. However, we'll leave this as our simple example for a plan, develop, build, and deploy system. We'll switch to the dynamics lens now to understand the process dynamics and see the flow of inputs and outputs over time. We will add and modify a few models for this lens. We'll start from the beginning of the process, and the work item generation is exactly what we want. We'll change, however, how often we're creating work items, and say that on average we're creating about 1 work item per day. We'll leave GitHub as a code repository, instead of changing the model variant here. And capture our development process within a manual task. A little bit different from the function lens before, instead of having a GitHub model represent that development process, we'll separate out that manual work. So we'll call this manual task here, development. And we'll imagine that we can do about 2 commits per day. Next, we'll line up the Jenkins job here. And for all the work item and code work, before we have artifacts, let's start to wire those up with connectors. So the work item will be the input for the development task. Developers will develop against those work items in Jira. The output from that development task is code. And we'll have the code commits automatically trigger the builds. That is, we're going to fetch the code into the build system on every commit, so we'll wire this output to both code repository ports here. And finally wire up that code push to Jenkins. As before, we imagine this build takes 10 minutes. Now we should work on the artifact portion of this process. So we'll have the artifacts be stored in Artifactory. And to create a little bit more interesting of a process, perhaps a what-if analysis, we'll not deploy on every single commit, but rather, have a deployment trigger. We'll use a separate, manual task, which dictates deployment timing. That task can be placed here. And we'll deploy on average, every week. We need to wire the output of that task to the fetch here, which will push along those artifacts to our deployment task. We need to change Jenkins to be a deployment tool for this particular process step. And then, as usual, wire up the inputs and outputs to connect up the process. We do also have our SonarQube model here, which we haven't quite built in yet. Let's switch this to be a probabilistic model, and say that, as before, the failure probability is 25%. And then we'll find a way to bring that into the process up here. So upon every commit, before we build, we're going to run this code quality check. We just want to move these models around a little bit to efficiently use the space. Not have too much white space in our diagram here. Alright, that's looking pretty good. And now, as a last step, we need our deployment to actually push artifacts to AWS. As a sort of measurement step, we'll bring in a stopwatch here to measure portions of this process. Let's imagine we're interested in cycle time. That is, how much time elapses between starting work on a work item and deploying that work item to production. To measure that, we'll add a stopwatch model and wire it up to the process. The work item generation is going to start the duration measurement. The deployment will stop the duration measurement. And again, just move around the models. Try to minimize white space. Use additional space in the canvas if needed. If you need more than just the screen amount of space, you can scroll and add more here. But this looks pretty good. We can certainly add much more complicated dynamics, bringing in, for example, ServiceNow for change enablement workflows, but this will work for now. Let's just do a quick check of our configurations, to make sure that they are all fine for this simulation. So we're creating a work item on average once a day. Development completes, on average, 2 work items per day. We're just going to store code in this GitHub repository here. And we're going to push it on every commit. Code quality is going to have a failure probability of let's say 25%. And building artifacts. We're going to say that takes about 10 minutes. The artifact repository. We won't have much to configure here. But we do want to make sure that we're triggering on an appropriate schedule for deployments. And in this case, we'll deploy every 7 days, approximately once a week to production. The deployment task itself, we'll set that to be similar to the build task. We'll have that be 10 minutes. And that is the same duration we used during the function lens analysis. Not much to configure on our deployment target here. We accept the AWS configuration, and same thing with the stopwatch model. So now we have everything wired up the way we like. We're going to measure the cycle time from this process and watch the resource flows. Again, you can bring in any of these models to represent your software delivery process, using rather generic models such as automated task, or more tool-specific models, such as the ones that you see here. Having the familiar colors and logos can help when you're sharing these models and collaborating around a process, particularly for what-if analysis about how you want to run your software delivery processes. Now let's begin to step through the simulation. We'll start clicking the Step button to watch the flow of our work items and our developments, artifacts and commits. So we have a work item that came in after about a day and a half. And we'll watch how that goes through. Interestingly, we have another work item coming in before this process is actually done, this development task. And now, that first work item is done from the development task. It will be sent through a relatively automated pipeline. There's a chance a new task comes in before that's done, but in this case it looks like the work was blocked by the SonarQube system, the code quality or security verifications. We need to further step the simulation to generate more work items and resource flows. So we'll just continue with this process. The next work item coming through did pass our code quality analysis. We can watch this work item make its way out to production. And look at that. We had a deployment right after we built those artifacts. One major change. And so that's going to make its way out to the AWS deployment target. And now we see an average for the cycle time measurement, about 2 days and 19 hours. We're going to want to run this a lot more to get a more stabilized average, and to reinforce our understanding of resource flows. We'll start to step a little bit more quickly. We'll do 10 steps at a time, so more time elapses, and more resources flow on each click. We run this a few times, just to start to get some more interesting data. In this case, since our deployment happens about once every 7 days, that's really going to be what drives this process. So far, we've ran about a week and a half of total time, and really, we could probably step this up further to 20 steps. Just to see at least another deployment. So it looks like we had another trigger here for the deployment. And as I do multiple steps here, you can see this average changing. We now have about a month of time. Let's go ahead and do about 2 months of simulation. I'll again bump up this value for the number of steps. Okay, so we have about 60 days worth of time, and in this case we see that the cycle time is about 2.5 days. So somewhat surprising in the sense that the only real manual task is that development task. Much of the rest is automated. If we're talking about cycle time and not, including the planning activities. We're delivering software pretty quickly here. And we see an average cycle time of about 2 days and 3 hours. As a stochastic simulation, the average cycle time is never fixed, but does converge. So you can run specific analysis like this with cycle time for your software delivery process, but you can also show this sort of simulation to stakeholders. Help them understand how work items translate into commits, how those commits translate into artifacts, and how those artifacts are deployed. Look at how things are batched and where there's waiting and queuing in the process, like what we saw at the beginning, where development was still working on the first work item when the second arrived. Again, we will generate a graphic for this process to share with stakeholders and collaborate around. And we'll save the simulation so that we can bring it up later. Hopefully you've seen with the Software Delivery Simulator, how you can develop an intuitive shared understanding of the current system, but also perform some what-if analysis to drive continuous improvement. We modeled a simple plan, develop, build, and deploy system here. But in some sense the value of simulation is increased as complexity is increased. When there's substantial complexity in the software delivery system, you can use modeling and simulation to develop a deeper understanding. And importantly, it's not just about an understanding for yourself, but also sharing that with others. Developing a shared understanding among the team about how we're delivering software today, how we're delivering value to customers today, and how we want to do that tomorrow. Thank you for watching. And for using the Software Delivery Simulator.